Optimal health for high performers. This is the Health Upgrade Podcast with Dr. Nawaz Habib.
Hello, everybody. Welcome back to the Health Upgrade Podcast. This is Dr. Habib, and I'm really excited about today's episode because it's one that is very unique for me in particular because I get to speak to the two people that developed some amazing technology that many of you have heard of, which is vagus nerve stimulation. And so JP, most of you know, is my co-host, and he's a big part of this journey along with our guest today, Dr. Peter Staats. I'm really excited for this conversation because I get to learn a little bit about the journey of developing this and how vagus nerve stimulation truly came to be in the world, non-invasive form, of course, and how we can then utilize that information and utilize that technology for upgrading the health of our listeners, the health of our patients, and the health of so many people that are suffering from chronic health diseases. So today's episode is very exciting, and I really do want to dig into this with you. This episode of the Health Upgrade Podcast is brought to you by Truvaga. Have you been looking for a simple way to feel calmer, think clearer, and sleep better? Imagine achieving this with just 2 minutes a day. I'm excited to introduce you to Truvaga, a handheld device that supports your nervous system through gentle vagus nerve stimulation. As a doctor specializing in functional health and wellness, I've seen firsthand how Truvaga has accelerated healing in my clients. I've used this device to help people with a range of issues, from sleep disturbances and heart palpitations to digestive dysfunction, nervous system imbalances, and mental wellness concerns. The results have honestly been remarkable. Truvaga is designed to catalyze and accelerate the shift in your body from fight or flight to rest, digest, and recover mode, helping you manage stress, maintain mental clarity, and unwind more easily. It's not just theory. I've witnessed its positive impact on real people facing real health challenges. The best part? Truvaga fits seamlessly into your routine. No need to carve out hours for wellness. Just 2 minutes a day can make a difference. It's a small investment of time for potentially significant benefits in how you feel and function each day. If you're curious to experience Truvaga for yourself, visit truvaga.com/upgrade. You can save $30 on your device by using the code UPGRADE30 at checkout. Remember, that's truvaga.com, truvaga.com/upgrade. It might just be the first step towards a calmer, clearer you, just as it has been for many of my clients. JP, great to see you as always.
Great to be here.
And Dr. Staats, it's an honor again to have you on with us. So thanks for being here.
Well, it's always great to be with you. And JP, great to see you again.
Peter, always good to see you.
So these two gentlemen work together to develop non-invasive vagus nerve stimulation technology for the cervical trunk of the vagus nerve. And Dr. Staats, I'd like to kind of dig into the history. Where did it all kind of start for you? What was that initial prompt to say, let's try to figure out an answer to why the vagus nerve is so unique and how we can utilize this? Was there a particular story that comes to mind?
Yeah. So first of all, I'd like to point out that there's 1,000 points of light that come together to create a focused energy. And this is one of those, in my mind, those stories where I had lots of different perspectives. JP, of course, brought a different perspective that's really nice. And then we all kind of came together to get this great focus where we're actually have something that I think is extraordinarily innovative in potentially changing the world, truly changing the world and how we think about medicine in general, wellness, longevity, and can be deployed across low economies and or not wealthy economies, but also into industrialized countries. So it's really something that could be extraordinarily impactful. But to answer your question, I was an anesthesiologist, became a pain physician at Johns Hopkins, and I started the division of pain medicine. And I started that largely because of my fascination with neuromodulation, the ability to use electricity to modify pain initially for me, but also we were working on high cervical spinal cord stimulation for movement disorders of the various types. And the whole area of spinal cord stimulation was just so interesting to me. And I could place an electrode, turn on a pattern, and I could take away the pain. I became fascinated with this as broadly, very broadly. not really focused at all on the vagus nerve initially at all. I became president of the North American Neuromodulation Society at one point and realized that there were people very focused on their area of treating cardiac perfusion or Alzheimer's or movement disorders with deep brain stimulation, epilepsy with vagus nerve stimulation. And people were really focused on how we can use electricity across multiple domains. So that's one of my 1,000 points of light. A second point of light that was interesting, it was deeply personal to me, was my son had peanut allergies. And I had started some research at Hopkins looking at the use of oral local anesthetics, which block specific C fibers and specific conducting fibers, to see if we could block the airway reactivity, and had just been kind of thinking about really high cervical or high thoracic spinal cord stimulation as a means to improving airway reactivity in anaphylaxis. And I met with JP. JP came down to a NANS meeting, and I remember saying, I got to go. And he goes, all right, I'll leave early. And we got on the train together, and we went back up to New Jersey, and he started telling me about the crazy Russian literature, of all things, that he's reading Russian literature about vagus nerve stimulation in airway reactivity. And to me, things started to settle in that there's an avenue here to use electricity to improve bronchial dilation or improve breathing, going down this pathway that JP had kind of brought to my ideas about the vagus. And I had been thinking about sympathetics and modulating the sympathetics. And we kind of riffed back and forth and came up with a plan to start to actually really look at this. So it was a broad interest in electricity. It was an understanding of what people were doing in the cardiac space and other areas. As an anesthesiologist, we were thinking about blocking sympathetic fibers to improve perfusion. And the obvious balance here is that you can activate the parasympathetics just like you can block the sympathetics and create similar effects. Now, that's a theme that we can come back to over and over and over again. But that concept of what do we know about sympathetic neuroblockade? What can we think about activating the parasympathetics, and how can we use this more broadly was very instructive to me. So, JP, does that reconcile with your memories?
Yeah, no, it dovetails very nicely. You know, my story behind it is not really all that dissimilar in that I was fascinated by some work that was done by one of your colleagues, a person I think you know pretty well, Ali Rezai, who I was introduced to. He was working at the Hospital for Joint Diseases doing some of those deep brain stimulation procedures that you were talking about. He was treating Parkinson's disease and essential tremor. And I was equally captivated by the magic of watching somebody who is literally shaking like a leaf going through what is actually about an 8-hour procedure to place a lead deep in the brainstem to find the right set of neurons to stimulate. And when you do that with the right pattern, all of the symptoms go away, but there's no side effects. In fact, the principal side effects are the surgical ones of actually then implanting the signal generator in the chest wall and having to snake this wire down through the skin. Is kind of brutal. But while they're actually finding the location, the patient's awake. So I was doing this work in the late 1990s and was really fascinated, wrote a whole bunch of patents with Ali Rezai and some of his fellows, and was really, really interested in getting back to it. Had to take a 4-year hiatus to run a company that was developing some spine products. But the moment that was sold off and I had the free time, I knew that I wanted to get back to this. And something that Ali Rezai had said to me, and we've talked about this on the podcast before, that really stuck with me was he said, anytime anybody had ever cut a nerve, and as a result of cutting the nerve gained a clinical benefit, there was an opportunity to stimulate the nerve instead and get the same benefit without damaging it. And so with that little bit of information, sort of like, knowing not to yell fire in a crowded movie house, I went forward and tried to look up situations where nerves were cut and somebody gained a clinical benefit. And that's where I came across that Russian literature that had indicated that they had done that back in the late 1960s, which actually was my birth year. they were looking at what the effects are of cutting the vagus nerve on anaphylactic shock. And so I was looking for something to get involved in, looking for something for neuromodulation. We had already started the company and we were developing a stimulator. We didn't know what we were going to go after, but we just knew that we wanted to be in this space. And that's when one of our good friends, a mutual friend, Gordon Donald, who's a spine surgeon who knew both of us, introduced us. And when Peter and I were on that train ride back from that NANS meeting down in Washington, D.C., back up to New Jersey, that's when we started talking about, well, maybe we could stimulate the vagus nerve and treat anaphylactic shock. And that led to us going to meet with a physician, Charles Emola, who was a colleague of yours at Johns Hopkins, but who at the time was at Columbia Hospital in New York and doing research. And we went to that Nets game and sat and talked with him about, hey, how could we potentially do some research together? And it all culminated in, I think, 2006, with February of 2006, doing the very first stimulation of the vagus nerve to treat anaphylactic shock. And the results of that led to treating asthma, which led to getting clinical results in humans that suggested that, hey, it also might have effects on headache, and looking up the literature and seeing how, yes, in fact, other people had used implanted devices to treat epilepsy, but had seen benefits in headache and then had studied it in headache. So we then developed a non-invasive technology. And that's really, I think...
But we should pause and talk about that whole journey right there.
Yeah, sure. Why not?
That's we got enough time here to talk about that. After we got our proof of principle with the guinea pig model, looking at an open insertion and placing the electrode on the vagus nerve in one area, and then placing a catheter into the jugular vein in another area, we showed this beautiful proof of principle, and we still have those graphs of how we could block the airway reactivity. We then went to a variety of different animal and cadaver labs. And we had no idea at the outset about a non-invasive approach. That took time to get to that point. And we figured out pretty quickly how to place a vagus nerve stimulator under ultrasound in about 6 minutes. And we figured out that we could actually do this, not really thinking at that point, for at least I wasn't thinking at that point, about non-invasive vagus nerve stimulation, but it was something that was practical. And remember that patients with status asthmaticus have a very high mortality, extraordinarily expensive. There's not a lot that was working at that time. It was epinephrine, it was steroids, it was antihistamines, but nothing worked particularly well. And we showed in some humans with placing the electrode that we could block that airway reactivity and improve FEV1, work of breathing, oxygenation. All of those things were really pretty remarkable. And that's when JP and Bruce really figured out a non-invasive approach that followed on how to make this like a digital drug. I'm reminded of Albert Einstein's quote, who said that the future of medicine is the future of frequency, and that the physician of the future will be a master of both the chemical side and the physical side. And he was referring to electricity at the time. And how we were, that innovation of saying we're going to do this non-invasively was so critically important for the field, to say that we can improve this like a digital drug, as effective or maybe even more effective than certain drugs. And you don't have to have surgery for it. I thought that was just an earth-shattering innovation at the time.
And just to riff off what you're talking about, and to introduce Bruce Simon, Dr. Bruce Simon, he's the Bruce that Peter was referring to. We started this work in 2006 in the animals, and it took us more than a year before we had enough data from multiple animal models to satisfy what the FDA wanted for us to be able to go into a human pilot study, which we did, and we did it at multiple hospitals, and we ended up publishing really remarkable data. And at the time, we had people on our board of directors who were both physicians, we had people who were well-versed in the medical device field, and we had people who were in the pharmaceutical business. And I remember talking to the people in the pharmaceutical business, and they knew of what it took and what the capabilities were of drugs to treat things like asthma attacks. And when they saw the data that we were generating, they said, not only would a pharmaceutical company never even attempt what you're doing, there's no way that a drug could do what it is that you're attempting and you are showing that you can do. And so we were very excited. And it really was a major shift for our company which I was serving as the CEO at the time and had to make the decision whether or not we were going to move forward with a full pivotal study using this percutaneously inserted, it was really a deep brain lead that we were, under ultrasound guidance placing in the vicinity of the vagus nerve and using that to treat patients who were in an emergency room setting or in the hospital to try to break the asthma attack that they were having. And we were having great success with that. But that was around, I always knew and always had in the back of my mind, this has to ultimately be something that's handheld, easy to use, non-invasive. And so we had this PhD in physics who was working with us, Dr. Simon. And I just kept coming back to him and saying, listen, our skunkworks project is to figure out how to obsolete everything that they're doing. And so we actually accomplished that. He did most of the work on that and accomplished it before we were actually able to start our pivotal study. So I had to make the decision, are we going to move forward with a study that is fundamentally still, bound to a hospital setting, or are we going to move forward with something that people could use in the privacy of their own home? And it was really pretty remarkable. Now, during this time, I'm a data junkie. I'm a science junkie. So we were studying it in models of sepsis. We were studying it in models of blood loss, hemorrhage. We were we were reading about its effectiveness, this therapy as being effective in things like fibromyalgia and work we knew it was already being approved for epilepsy, and it was being approved for depression, and it was something that people were studying in obesity. And I was in the back of my head saying there is either something exceedingly fundamental that we are doing that could touch all of these different fields, or this is really fake and we're selling snake oil. And given the fact that the FDA had approved it for multiple things at that point, and that they were looking at our data and approving us to run large clinical studies in patients who were in distress, I had to assume that it was real. And so we had to figure out how it worked, why it worked, and where best to apply it. So it's kind of exciting when that day came that we had the non-invasive approach.
Yeah. But it wasn't a non-invasive approach, as you recall.
I do.
We developed lots of non-invasive approaches. So think about this again. I'm an anesthesiologist. We put people to sleep. And one of the horrifying things for us is when you put someone to sleep and the lungs collapse and you can't ventilate a patient. We give that same drug that I was talking about, local anesthetics, to try to block that from happening. So we developed a nasal cannula with a little balloon in there that would stimulate the vagus nerve from the inside out, so we could use for breathing. Now, that's great for an OR anesthesia, not so great for a headache.
It's easy to do.
I saw a picture of my wife placing this this tube down Bruce's nose to, test it out. Did this work?
But the funny thing was that Bruce thought it was fine. That snaking this pediatric NG tube with this special partially porous saline bag at the end of it that you could conduct through up his nose and down his throat was something that for him wasn't that disturbing. It was something that he was fine with because he had had a turbinectomy. So he had previously had nasal surgery that had just made that like a superhighway. So it was easy to get. For anyone else, you teared up, you were gagging. It was a terrible experience, but he was the guinea pig that tried it on himself. And so even though he thought it was a great idea, and maybe it would have been okay for patients who were under anesthesia, not so much for somebody trying to treat an asthma attack at home. It wasn't going to work.
Yeah. That would have been a challenge. But, look, it's a process in trying to figure these things out. And this is one of those areas where I think having great engineering, great ideas, and just kind of a little medical background coalesced into coming up with a better mousetrap.
Yeah. And in fact, I remember I've talked about this before, but it's truly one of the great moments in my life, from a medical standpoint, was when one of our colleagues who had asthma was actually suffering with an asthma attack, didn't want to use his albuterol, said he hated the way it made him feel. And he was just literally sitting there laboring and wheezing. And I said, John, would you be willing to let us try our first non-invasive approach, which was really just, let's just say, an unintended use of a very expensive piece of equipment that we had purchased? And he said yes. And fortunately, Dr. Staats' wife, who's also Dr. Staats, was there, and she said she would oversee it, and she thought it was safe since it was a device that was put on other parts of the body, no problem. And we tried it, and it stopped his asthma attack. It stopped it in its tracks. Now, that device costs $80,000, so it's not something that is a practical thing, but it really gave us hope that if we focused and made something non-invasive, we could figure out how to do it so that it could be used at minimum without having to break the skin, even in the medical setting. But ultimately, it led to making a simple handheld device.
And JP, you may want to comment a little bit about this. This extraordinarily expensive device turned itself off after 2 minutes because it overheated.
That's right.
Which is why today our device, a dose, is considered 2 minutes, because that's what we got experience with. We could do it for 2 minutes before it overheated. And now we've got it all figured out, so we could go forever and ever and ever. But our dose is 2 minutes based on that history, similar to why why our railroad tracks distance apart. It's because that's the distance of two cows' behinds that they could get on a moving cart back in the Roman era. So it's really one of those.
That's why the chariot's wheels were that width.
Yeah.
But the funny thing is, I oftentimes, and I won't say criticize, I just remark that and recall the fact that one of the early individuals who came forward and was really impressed with what we did was a man by the name of Rhys Terry. And Rhys Terry was one of the founders and was the CEO for a while of the real pioneers in epilepsy, in treating epilepsy and ultimately also depression with vagus nerve stimulation. And they developed an implanted device. And when I got an opportunity to talk with him about their development process, what he told me was that they had taken dogs and given the dogs a lethal dose of strychnine. And, being a dog lover, I hate that, but that's the model that they used. And the dog goes through a period of continuously seizing. So it's a seizure model. It's not really an epilepsy model, but it's a seizure model. And in that model, they exposed the vagus nerve, they placed the lead around the vagus nerve, and they stimulated, and they were able to stop the seizing. And, truly a remarkable effect that they could have in such a robust model, such a toxic model of seizure. But what they found was that the seizures came back about 5 minutes later. And so their thesis was that the device needed to be on every 5 minutes. Well, I listened to this and I said, that's really an amazing day in science. I wish I had been there, but that's not naturally occurring epilepsy. Do you have any evidence that in epilepsy, you actually need to have it on every 5 minutes? Or is one stimulation enough that will carry forward for some period of time in being beneficial in preventing the seizure from occurring? And what we hit on was the fact that, people have the little magnetic wand that they can turn the device off, for some period of time if they're giving a speech and they don't want it, affecting their voice while they're doing it. Was there any increased number of seizures that occurred during the period of time when people for an hour or two would have it off? And the answer was no. And then I said, well, were there any clinical studies in which you did not have the device on every 5 minutes? And he said, yes. In our very first pilot study, which we did in epileptic patients, it was only on for 1 minute per hour. It was a safety test. And I said, well, did you find that it was clinically effective at 1 minute per hour? And he said, yeah, it worked great. And so I said, so why did you go back to having it on every 5 minutes? Did the FDA never ask you to dose range the therapy? And he said no, that the FDA had never dose ranged it. And for their purposes, it was beneficial that it only needed to be on every 5 minutes. Didn't need to be on all the time, which meant the battery would last longer. And it didn't need to be on only once every 6 hours, because that would be difficult to explain to patients why they had to go through a surgery if something only had to happen once every 6 hours. So they just left it at once every 5 minutes. I sort of say that, and you can probably tell the way I'm saying it that I'm sort of saying they're doing something that's not really necessary. We don't know for a fact, but we're kind of doing the same thing, because the 2-minute dose is based on something that's not clinical. It was based on just a technical limitation of the machine that we used to first test our signal. But 2 minutes isn't very long. Could you potentially get the same benefit at 30 seconds? I think for certain things, the answer is yes. For other things, I think you actually need to do multiple doses, but maybe 2 or 3 doses. That's usually about the limit.
But I'll push back on that. I just think that there are times where we're dramatically underdosing. So again, this is not an FDA, indication as of this point, but we've done a series of studies now in acute stroke, both in animals and in humans. And what we found in those studies is 2 doses is just not enough. There is a dose ranging effect that we see as we increase the number of doses in our preclinical as well as in our clinical trials. We need more. And I actually suspect that there are times where people are using our devices off label where we're probably underdosing people.
Anecdotally, I know it's not evidence, and the plural of anecdote is not either. But in the case studies and the pilot studies that have been done in things like gastroparesis seem to show that, especially in gastroparesis, 2 doses is not sufficient, in a day, 1 in the morning, 1 in the evening. In those cases, 12, 15, 18 doses per day is what's required, at least at the beginning. For many patients, the data seems to show that over time, they can wean back from that, and maybe they will get to the point where they only need a maintenance dose every once in a while. But really at that very beginning, and not sure why, but maybe it's just that gastroparesis is something that requires a lot of neurogenesis and synaptogenesis in the enteric nervous system. I don't know. But that's another example. So I am in agreement. It probably does vary case to case.
Yeah. Disease by disease, patient by patient as well. Yeah.
What was the prompt to go from an internal stimulation with the nasal cannula to an external stimulation on the neck at the carotid sheath? Like, what was the thought process there, and how did you then determine, okay, let's find this exact location, and how do we then ensure that we're getting that stimulation occurring correctly?
So I know the answer for me, which is that when we were going after asthma, it was pretty clear there's about, as Dr. Staats just said, there's about 500,000 people in the United States every year who go to the emergency room for an asthma attack that has failed albuterol at home. The inhalers aren't working. There are thousands of people who die worldwide, tens of thousands of people who die worldwide every year, literally with an albuterol can in their hands. They have the albuterol with them. They are trying to use it. But the use of albuterol repeatedly, especially for people who are unstable with it, leads to a greater degree of sensitivity. So it's like overusing NSAIDs. The more you use the NSAIDs, the more you're going to need them, because they're masking the symptoms, but they're actually making your risk of getting the headache higher. They call it medication overuse headache. The same thing occurs in asthma. The more you use the albuterol, the more likely you are to have attacks. So what we said was getting this therapy to the point where it could be used in the emergency room was a wonderful thing. There's 500,000 people a year who are looking at multiple day stays in the hospital if they get admitted. I mean, in fact, you spend more time in the hospital with an asthma attack if you're admitted than you do if you have a 1-level spinal fusion. Okay, that's how much time there is that you have to spend there. What we looked at, we said, but there are tens of millions of people having, tens or hundreds of attacks per year, where what the medication they're taking is actually making them more sensitized. It's actually worsening their underlying condition. We know that the therapy doesn't do that. We know that vagus nerve stimulation, when used in that setting, does not make you more sensitized. It actually makes you less sensitized. it actually has a much longer prophylactic benefit than a shot of albuterol. So we were excited about the idea of getting it out of the hospital setting. We wanted to get it into the hands of the patients so that they could use it themselves. We knew how safe it was, and we said, let's find a way to do this. And we were the first ones to do it. We have, we have the patents on it.
And look, when you've made the decision that you're going to stimulate the vagus nerve, you have a number of choices. You can go inside out. You can go surgical. You can go auricular. And there's obvious advantages to being able to take a handheld device the size of a shaver and place it on the neck. It's something everybody can find their own carotid artery and do this. So that from a practical consumer electronics, medical use, this is a much, much better approach. And I'm sure you guys have covered this on the show before, but there's some question about the exact number of fibers in the ear versus in the neck. Rough numbers, and we talk about left and right, but rough numbers, there are 1,000 fibers in the ear, rough numbers. There's roughly 160,000 fibers in the neck.
On each side.
On each side. So on each side, both for the ear too. So I guess that would be 2,000 fibers and 320,000 fibers. But roughly a huge order of magnitude difference. But that's not the only difference. If you're only stimulating the auricular branch of the vagus nerve, it goes to a different area in the brain. It goes to the trigeminal islands in the brain with all of the fibers going into the brain, nothing going directly down to the lungs. Whereas in the neck, you have fibers that are going afferent and efferent, both. It turns out that it's probably more important going afferent in the lungs, but probably more important efferent with inflammation. So this is a much, much better target. And another little nuance that people, only the real neuromodulators might get, is that it's actually a little bit better to place the electrical fibers not on the nerve, but very close to the nerve, because that allows you to target specific fibers throughout the entire neural structure there. And so whether or not it's a peripheral nerve stimulator for leg pain, you don't want to be right on the nerve, but you want to be really close. I suspect we're going to find the same thing here, that we're going to have some significant advantages by being very close to the nerve without being right on the nerve. And that's a little nuance that adds into why the neck is really a good approach.
Yeah, I'm just going to second that and say that in the animal work that we've done, there does appear to be some difference between stimulating the auricular branch and stimulating the cervical branch, not just in the amount of time. Typically, people who are using auricular stimulators have to use them for, the shortest I've ever seen is 20 minutes. The longest I've seen is 6 hours per day, which is a long time to have something buzzing in your ear. You get, just by orders of magnitude, you get a much stronger signal. Now, at the same time, I'll say, just to give both sides of this argument, there are studies in fMRI studies that seem to show that the same areas of the brain are lit up using the auricular stimulators and the cervical stimulators. However, that would suggest that both have similar effects. And at least in some animal studies of stroke, that does appear to be the case also. However, there's been a recent study published in Nature's Scientific Reports about the use of by the military studying vagus nerve stimulation for cognitive improvement. So one of the benefits, we've been talking a lot about treating medical conditions, but one of the things that vagus nerve stimulation can do is actually enhance cognitive performance. In shorthand, it makes you smarter, makes you able to learn things more quickly. And the study that they were doing was at the Defense Language Institute, which is, I guess, the equivalent of like the CIA Foreign Language School, if you watch movies, And what they found, because they studied both, they studied the auricular stimulators and the cervical non-invasive stimulators. And what they found was that they did not get the benefits from the auricular. They only got the benefits from the cervical, and that the benefits were pretty extreme. I mean, I think we've talked about this before, 30% improvement in focus, 40% improvement in recall, and 50% improvement in learning rate. So, these are high-performing people who are still getting massive benefits. So, there's some debate as to what the reason is and why it is doing what it's doing, but it does appear to be that the cervical is a superior approach for that.
Yeah, no, I agree with you, and I agree with all your rationale there. But I would also just say there's too much data out there with an auricular branch to disclaim it, because there's a lot of really good things that can happen with an auricular stimulator as well. But I agree with JP that this has a lot of both theoretical and probably practical advantages in using a 2 minutes of stimulation in the neck, controlled by the patient at all times. So there are pros and cons, but honestly, every time I see, most of my work has been in cervical non-invasive vagus nerve stimulation, but I have worked in the ear as well. But anytime I see that there's success with an auricular stimulator, for example, there's a couple of studies out there with long COVID, and now we have one with cervical NVNS as well. But every time I see that, I say, and it's positive, I say, wow, that's really pretty cool. That's really fascinating. I wonder what they could do if they had a better access point. So it's an exciting area. I think a lot of people study auricular vagus nerve stimulation because they don't know that they can get access to cervical NVNS. And there's just a huge, huge interest across the globe in this whole area of medicine at this point.
Would you say that there might be some apprehension simply because it's located so closely, so intimately to the carotid artery and jugular vein that people almost have this predisposition that if I go there, I could hurt something?
Yeah. So the number one question that I've got, I think I've reviewed every complication we've ever had. And I speak with the doctors when they're concerned about using the device. And the number one concern I get is that we're going to cause bradycardia. Everybody's heard of a vasovagal event where the heart rate slows, et cetera. And that's the number one concern I have. And practically, I would be concerned too if I didn't know what I know.
Break that myth,
the
sir.
Truth
Break
is
that myth.
The device has been structured and built to not activate the fibers that go to cause the slowing of the heart. So we can use the device on the maximal dose, maximal strength, and be one log level or 100 or tenfold off of where we would need to be to activate the fibers that cause slowing of the heart. So it is the number one concern, but this device in particular, it's an important point here because this device has been tested, found to be A, not activate those fibers, and B, found to be effective in a variety of different disease states. What concerns me as someone who's deeply involved in this field is some of the kind of Me Too companies that come out and are not using a validated electrical field. They're making all kinds of claims. And if it doesn't work, people are going to sign this off and say, oh, it doesn't work. But there's a lot of background work that went into developing the electrical field that we're using today. So it's a word of caution out there to your listeners to say, if it's not working, make sure you've understood which waveform is being used.
Yeah, $250 million of research and development went into this product. So by all means, don't go with the knockoffs. But I just want to, sort of follow through on some of the other things that this has been studied in, not just by the people that we worked with, but by others, because there's so many areas in which vagus nerve stimulation, as I alluded to before, fibromyalgia. They've been looking at it in Alzheimer's. We've been doing work in Parkinson's disease. I'm doing work now in partnership with people up in British Columbia on preventing autism and schizophrenia. Your expertise, in many areas, but your career has been much focused on pain. Perhaps, it's an area that we haven't gone into. We talk about what happens up in the central nervous system with respect to neurotransmitters and mood and anxiety and cognitive performance and other things. But why don't you give us the 5-minute lecture on what pain is and what different types of pain vagus nerve stimulation can work for and what maybe it can't work for. Because I always tell people, vagus nerve stimulation is not a cure for anything, really. What it is it makes you more capable of dealing with the things that are affecting you so that you can heal faster, you can not suffer consequences. But let's talk about pain.
Yeah, so look, it's a really great question. And this is an area, ironically, that, I've been a pain physician now for, 35 years in this space. And then, working with you on this company since 2004, I'm a little bit embarrassed that we've not gotten farther in the area of pain. So what I'm going to say now is very conceptual with some practical issues as well. The two greatest healthcare crises facing America today is uncontrolled pain and addiction. Those are our two greatest costly healthcare crises. Arguably, Alzheimer's and other things are out there too. But these are extraordinarily costly therapies that I think are extraordinarily poorly managed right now. Let's start with addiction because that's easy. There's already a device out there that is an auricular device that's been approved for the treatment of addiction. And what they are doing is managing the withdrawal symptoms and the desire for more opioids with a device with vagus nerve stimulation. Doug Bremner, who is a world-renowned psychiatrist up at Emory, has a $6 million grant from NIDA to do a real pivotal trial using cervical non-invasive devices for the treatment of addiction. Many pain physicians struggle with what to do about their patients who come to them on high doses of opioids because it's really hard to get people off of opioids. So I put that into the context of what's the pain problem because it's hard to tease apart sometimes. And I think in the context of trying to get people off of opioids, whether you have a true addiction problem or you're going through withdrawal when you try to lower your dose or you have opioid-induced hyperalgesia, all of those things theoretically could benefit from vagus nerve stimulation. Now, again, our device is not approved for that yet, but this is something that would be something that should be in this context. $760 billion are spent on addiction every year. So if we have a better strategy, that would be good.
Let me ask you a quick question. Emmanuel Lerman, who's a researcher in this field out on the West Coast, I think he's at UCSD. He is very interested in doing some work looking at how opioids activate the immune system in the central nervous system. And that what he finds is that in patients who have opioid addictions, that there are areas of the brain where the microglial cells are very activated. If you use certain ligands, MRI, you can see them lit up, and that it is actually that pain experience that people have, the disturbing and uncomfortable experiences of withdrawal, are really those microglial cells releasing inflammatory cytokines in the brain that are leading to all of the neurotransmitter disruption and brain fog and pain experiences that they're having. Vagus nerve stimulation, we know, can downregulate microglial activation downregulate the inflammation that these microglial cells are experiencing. Do you think that is, or to what degree do you think that may be the mechanism by which vagus nerve stimulation is having a benefit for patients going through withdrawal?
So I think that's certainly part of it. And I was going to segue to the next little level here. Pain is kind of broken up into four areas, a little bit artificially: nociceptive pain, neuropathic pain, nociplastic pain, which is kind of centralized pain, cancer pain. There are others, arguably visceral pain versus somatic pain, et cetera. But one of the areas that's really challenging is neuropathic pain. And this is not an area where we have a lot of clinical documentation of this working. Well, that's not really true. I'll explain where we do have some information on that. But there's not a consensus on what is neuropathic pain. We have tried all kinds of different strategies. And as a pain physician, use of anti-epileptics to try to help with pain, use of antidepressants to try to help with pain, use of opioids to try to help with pain. And we can go down this long list of things, but without a real good understanding of what it is. Now, to JP's point, I believe, and I'm probably in the minority opinion here, but I believe that neuropathic pain has quite a bit of modulation of those microglial cells, both at the dorsal ganglion, in the periphery, and centrally. And there is a production of these pro-inflammatory cytokines. One of the key ones is TNF-alpha, but there are others as well that I think are responsible for neuropathic pain. And we're kind of missing the boat to some degree in how we've been treating people over years. In our new textbook, Vagus Nerve Stimulation, shameless promotion there, just published last week, a chapter on use of vagus nerve stimulation in some complex disorders like neuropathic pain. So there's this conceptual area out there, but we really need to do some more well-designed clinical trials on neuropathic pain. Now, let me just say, there's a device that's an auricular device that is not just the vagus nerve. It stimulates cranial nerve 10, cranial nerve 5, cervical nerve root 2, and cervical nerve root 3. So it's getting 4 different nerves, and it's implanted for 20 days on the ear, placing the little electrodes, and that's approved for diabetic neuropathy pain. Now, that's a really interesting story because it also looks like that device probably also helps with diabetes. It is lowering glucose levels, which is one of the other pathways that we should talk about. But this is support that part of the problem is these pro-inflammatory cytokines that are, released by astrocytes and other microglial cells to sensitize nerves. And there's a lot of lines of evidence that's pointing to that, but that's not where the neuropathic pain researchers are going right now. But I think they're going down the wrong pathway, and we're going to come back to this as being a really important area. So people can give TNF-alpha inhibitors, which now, ironically, just last week or 2 weeks ago, 6 weeks ago, there was a paper that was published showing that these TNF-alpha inhibitors may cause increased central inflammatory lesions, which is concerning. And sometimes when you block completely one receptor system, systems go around that as well, which is one of the benefits of having a therapeutic avenue like VNS, which broadly blocks things. It doesn't knock out all the receptors. It takes us back down to a normal level. So opioid addiction, neuropathic pain. And the next one would be inflammatory pain. Now, this is an area where I'm 100% convinced, and JP, you and I have riffed on this over the years on this one, that we are extraordinarily effective. Rheumatoid arthritis, Sjogren's disease, lupus, these pro-inflammatory disorders are modulated by the autonomic nervous system. And the autonomic nervous system will control, through those macrophages and microglial cells, the production of these pro-inflammatory cytokines. And modern medicine has not spent nearly enough time working on this. The Set Point recently published their data, which was highly statistically effective. Arguably you could get a better clinical effect, but highly statistically effective in a very recalcitrant group of patients using an implanted vagus nerve stimulator. So again, when I see these things coming forth, yes, it's an implant. I believe we can do a lot of the same things non-invasively as we can do with an implant, but that's neither here nor there. This will control inflammation.
You touched on something that's really important. And just as an aside, I'm not sure you can have pain without inflammation because one begets the other and it's bidirectional. So if you're experiencing pain, there is some level of inflammation that is also occurring, whether it's only central or otherwise. But one of the things that inflammation does is it also disrupts metabolism, cellular metabolism. And so, because part of the reason why inflammation is occurring is to signal to the cell that the cell needs to sort of reduce its production of antioxidants. So your glutathione, your melatonin, your superoxide dismutase, catalase, those levels all drop. And now you're starting to produce more reactive oxygen species to create an inhospitable environment inside the cell in case of a viral or bacterial or parasitic infection. And what that ends up doing over time is disrupting the mitochondria themselves. And so one of the things that vagus nerve stimulation we know does, and you touched on this, and I'm just going to throw it out there, one of the things that vagus nerve stimulation does is it also supports healthy mitochondria. So, you were talking about the very expensive conditions. There's also mitochondrial dysfunction, which is involved in almost everything. So what I'm thinking is that maybe that neuropathic pain, and maybe this is a blue sky, that neuropathic pain has to include, to some degree, what I'll call a plastic change in the way you're perceiving sensory information, or even anticipating sensory information, or interpreting sensory information, that those neurons are actually suffering with a metabolic problem. They've got a mitochondrial dysfunction, and that the permanence of that issue is a function of a local inflammatory signaling that doesn't need to be there that long, and it primes those neurons by disrupting their metabolism. and they're now permanently dysfunctional with respect to their mitochondria. Be interesting to understand the energy of those neurons that are involved in neuropathic pain.
Yeah, no, you're entirely correct, and I don't know the answer to the DRG mitochondria in neuropathic pain, which is a great question. But we know now that everything you just said was largely correct. That there is mitochondrial dysfunction that's associated with a lot of different disorders, and I just caution the reader that, or the listener here, that a lot of your westernized medical doctors remember what a mitochondria is, but don't know how important it is in medicine, broadly speaking. So having therapies, whether it's VNS or any other therapy that improves mitochondrial function, I think is going to turn out to be more and more important.
Listen, it's exercise, diet, and sleep, and those three things are really, really important for mitochondria. If you're filling yourself with sugar and you're filling yourself with processed carbohydrates, and you're eating basically 16 hours to 18 hours a day, and you're not giving your mitochondria a chance to use ketone bodies or fat, short chain fatty acids or other things for fuel, and it's just relying on you're headed for an early grave. I mean, even I've been looking into cancer rates based on BMI, and there are very prevalent cancers that didn't exist 100 years ago or were very rare 100 years ago. And the incidence rate or the prevalence of those is 5 times higher for every time every jump you make into a new category of BMI, you're increasing your odds of getting that cancer dramatically. So cancer is really a disease of mitochondrial dysfunction. We had Thomas Seyfried on, and yes, there's other things that are involved as well. But I mean, the effect of mitochondrial dysfunction is profound.
Yeah. So Navaz, you're seeing the riff in real life here, because JP kind of went off in this little tangent, and I'm going to pull him back into a different little tangent, is to say we actually have a patent filed on telomere length, which is associated with long-term survival, because we know that stress, broadly speaking, does increase the telomere shortening. And we know that vagus nerve stimulation can modulate stress and stress telomerase type compounds. And so not only is it an early grave, as he said, it's literally a marker of an early grave.
So it's accelerating aging. So, that's really, now we're getting into something. I'm actually in the process of writing a paper on this. But yeah, you're absolutely right that vagus nerve stimulation increases telomerase activity. So just for the listeners, your chromosomes have to get copied. Every time a cell divides, it has to get copied. And that DNA, that copying mechanism, as it gets to the ends of the chromosomes, it can't actually copy all of it. It loses anywhere from 50 to 200 base pairs each time it gets copied. So what Mother Nature has done is she's put end caps on the chromosomes, and there's basically this repeated six nucleotide base sequence that's just repeated hundreds of times. But over time, that shortens, and so you get to the point where when that copying occurs, it's now eating into real genetic information.
The analogy,
and that's the point.
Yeah, the analogy I use there is the photocopier, right? Like you've got an original piece of paper and an original image. You photocopy that. It doesn't quite turn out at that 100% rate of recreating the original. But then if you copy the copy, and then if you copy the copy again, and you copy the copy again, it slowly degrades over time. The actual original image, you can tell a vast difference between what was originally there and what ends up being there on copy number 8 or 10. And that's essentially what's happening in our body, is we're slowly degrading what the copy quality of the chromosomes by breaking down the telomere length. And that's essentially the analogy that is easily applied to that concept.
Yeah, the guy who's sort of the big name in this field is Leonard Hayflick. Leonard Hayflick was looking at the fact that as his cells in the petri dish divided, they seemed to come up on a limit. They could divide up to, 30 times or something like that, and then they just stopped dividing. And one of his colleagues said, well, maybe they're just getting old. And that literally that offhanded comment made him say, this may be one of the mechanisms of aging. And it actually is one of the hallmarks of aging, this telomere attrition. But we have within us a gene for a protein called telomerase. This enzyme replaces that 6 nucleotide base. So it's basically rebuilding those end caps so that you can continue on longer. Now, you have to be careful about that because in some cells, that can lead to unregulated growth and cancer. But for stem cells, it's particularly important because one of the hallmarks of aging is stem cell exhaustion. These cells reach a limit and these stem cells don't work anymore. But if you remain in a parasympathetic state and you have that vagus nerve stimulation stimulating this telomerase to be expressed in those cells, you see those telomeres grow. So it's one of the many things where vagus nerve stimulation is truly an anti-aging treatment.
So let me bring us back to pain for one last point that I think people might be interested in. When I was a young pain physician, there were a variety of things that I was taught, some of which made no sense to me. One of which was the incidence of chronic pain that develops is directly related to having abuse as a child, sex abuse or other abuse as a child. And, my initial framework on this was, well, they must be depressed or must have some other emotional problem, which is now allowing them to heal. But as I've learned and I've studied and I've thought and I've read Steve Porges's work on polyvagal theory, which many of your readers will know, I've actually come to think of this a little bit differently. I suspect that a lot of our patients who aren't doing well are not in a place where they can heal. And that's kind of a little soft terminology.
That's accurate.
It's not in a place that they can heal. And that's due to actual damage or scarring or something on the vagal complex. So you have a dorsal and a ventral vagal complex. And if you are not in a state where your vagus is actively working, particularly your ventral vagus is actually working strongly, your cells are in this mitochondrial dysfunctional state, which is really the connection of mind-body interface here. So we've got mind, we've got the brainstem, which we just think, okay, that just keeps us alive and helps us breathe. But no, that is where the vagal complex is. And that is not just a highway between the two, but it is controlling. It is the peripheral sensitization that you're seeing in the body. It's controlling all kinds of things. And so some of these chronic pain patients who don't do well, if you go back and look, they've had, with the therapies that I traditionally offered people, they've had something else. And I suspect I've missed, as every other pain physician out there has missed, the import of the vagus and the vagal complex on controlling pain. And if we do therapies directed at that in conjunction with some of the traditional therapies, I think we're going to do better over the years to come. But again, concept not shown to be practically effective, but for the patients with chronic pain who are interested in this topic, who have gone through their doctors, who haven't done well with traditional therapies, it's something that you see in yourselves, trauma, et cetera. Consider that there may be other things. It's real. It's not that you've been maligned or something of saying, oh, this is all in your head. It's actually not in your head. It's all in your brainstem.
Well, I always say it's not here. It's back here. It's inside your skull, but it's back here. You quoted Einstein before. I'm going to quote him again when he said that you can't simultaneously work towards peace while preparing for war. And, I'm not so sure about the politics of that, but I certainly am sure of that, physiologically, that if your body is in a state of fight or flight, you cannot heal. And a perfect example of this, and I think it's such a wonderful story. We had David Yoder on as a guest a while back, and one of the stories that really stuck with me when he told it to me, even before we had him on, was a story of a person who went through an extremely awful trauma. He lost his son, and at the time that happened, he was bitten by some bugs, and he had a rash that persisted on his legs for years. I mean, literally, it looked like his body he had been bitten by bugs all over his legs for years. And it wasn't until he met David Yoder, and David Yoder asked a very interesting question, which part of the reason why I'm bringing this up is it was triggered by something that you said, which is he didn't say, how long have you been experiencing this? He said, what was going on in your life when this started? And that is a very different question. And yet it appears virtually the same, but he says that that's what led the patient to say what horrible thing had happened to him. And that led him to say what you need to treat your rash on your legs is grief therapy. You need to go and grieve this so that you can move past it and get your body and your brain and your nervous system out of fight or flight. Because you've literally, we always talk about fight or flight, but as polyvagal theory says, there's fight, flight, there's freeze, and then there's fawning. Okay. And it's like the 4 F's, and the third F is that freezing. And literally, you can literally freeze your body in a state that can't heal. And you're stuck there for an indefinite period of time. So one of the things that I like about vagus nerve stimulation is it forces, even if it's difficult for you to do that because your psychology and the trauma is forcing you into that fight or flight state just by recalling it. Vagus nerve stimulation has the ability, much the same way some of these, these hallucinogenic therapies that people are using, ayahuasca, and things like that. It drives the autonomic nervous system into that rest, digest, and restore state, even though you are thinking about it, even though you are processing ibogaine and things like that, which they're illegal in the United States, and I'm not suggesting people use them. I think there's a better way of doing it, which is through really activating the vagus nerve.
I have a very similar story. I'll share it after. Go ahead, Peter.
No, please go ahead.
I have a patient who I've been working with for years, and very similar story to the one that Dr. Yoder shared. His patient lost a child, and in this case, my patient lost her son. It was a car accident, and she blamed herself for letting him go to wherever he was going, and he passed in a car accident. And she blamed herself. And every year on the anniversary month of his passing, she would have heart palpitations that began around that time. She didn't notice it until they were gone, and I'll tell you how they went away after. But she said every year during the month of February, it was an incredibly difficult time for her to feel like her body was healing. She had literal heart palpitations that would pop up, and it was entirely a perceived stress. It was the perception of a stressor that was driving her body into a state where it was incapable of healing. It was in that freeze state. I started using vagus nerve stimulation with her, and that was the moment that really shifted. And we say this all the time: your body cannot heal in fight or flight state. If your perception, if your stressors, if something is driving you and keeping you in that fight or flight state, your body is incapable of sending signals to the immune system to initiate the healing response. And so what we need to do is shift to that parasympathetic healing response. I shared that with her, and we started using vagus nerve stim, non-invasive, exactly the device that you guys both developed. And on the most recent anniversary of her son's passing, she said, I didn't have any heart palpitations. Something was different this time. She went back to her primary physician, had testing done. They said, things are looking way different. And we're looking back and we're seeing that these palpitations were happening every year for the last 6 years, except this year they didn't. What's different this year? And she said, I started using this device, and it started keeping me into this state. And she said, she sent me this huge note. And at the end of it, she said, I finally feel like I'm healing. And for me, that was like goosebump moment. My entire thought process, everything shifted. But it was exactly what you're talking about here. It's this, yes, there's a grief, there's a trauma, something that occurred in this person's life that shifted the perception through which they saw the world. And it pushed them and kept them in that fight or flight state. And this is a very common story that we hear now with all of our patients, and that there is some form of trauma, some life event that triggered this push towards fight or flight. And so this tool is great for accelerating or catalyzing that move towards rest, digest, recover, restore state. And so that's really just what I wanted to share there.
Yeah, no, I think that's really important. And, one thing that I find important in kind of mapping our future is having a theory of why things happen. When when a patient has been told, were you sexually abused as a, recalls that they were sexually abused as a child, and the doctor says, well, you were, there's a problem with you because you were sexually abused as a child, that puts the blame on the patient and makes them a weak person or something that it's hard to, in my mind, overcome. Go to see a psychologist because you don't have the fortitude to survive this kind of thing. And that's really not helpful. But having an orientation that says there's a physiological problem that occurs when these things happen, and we need to address that, I think that is a better avenue than saying you're a weak person, so to speak. And this is an area where things start to pull together from the trauma world, from the medical world, from the Eastern philosophy world. We're all pulling together at that brainstem.
Yeah. No, listen, ultimately, I mean, I realize this is a bit fringe, but there's legitimate scientific papers out there that are showing or are arguing that consciousness itself is an offshoot or is an emergent property of the autonomic nervous system. And the awareness of self is something that is just sort of happens as a result of the autonomic control system.
And when there's a disconnection to that awareness of self, then we create this perfect storm that enables a mental health type of condition to pop up, right? When we lack that interoception is that piece to the puzzle that is missing in almost every mental health condition, that there's a disconnect between what you're thinking and what you're feeling internally, or you're not able to fully experience those internal functional feelings because something has happened in that brainstem. Some sort of breakdown has occurred at that vagal control unit in the brainstem. And so
it's in our language. We say, I need to get in touch with myself. I need to go and just get within myself. I need to get back in touch with myself, my feelings.
Yeah, I need to reconnect with myself. Exactly.
Yeah, and it's real.
I love this. This has been one of my favorite conversations, particularly because of my relationship with both of you and watching how vagus nerve stimulation developed. I want to ask, as we kind of lead to the end here, Dr. Staats, in terms of the future, you mentioned that the future of medicine does heavily involve us starting to ask that question of why a lot more readily. I think functional medicine is leading that approach. It's exactly that question that's being asked in every patient interaction is, why is this situation happening? But I want to ask, with regards to vagus nerve stimulation, with regards to neuromodulation and the work that you do, where do you see healthcare going in the future? Where do you see vagus nerve stimulation kind of plugging in?
Oh boy, that's a tough one. So the most famous philosopher of science is a guy named Thomas Kuhn. He published a series of books back in the 1950s. And one of the things that he said was that having a paradigm shift is extraordinarily difficult. And he describes the theories of electricity back in the 1800s and says there were almost as many theories of electricity as there were people studying it. And coming through a paradigm shift, and you can think back to Darwin and Darwin's time of, he had the same information that Lamarck had and others had. And yet he was able to come up with a change in orientation. And that took 50 years to this really, people start thinking differently. Galileo, others throughout time. I think the science is there that we're ready for this paradigm shift to really embrace the autonomic nervous system, to really embrace making changes in our diagnosis and in our treatment strategies that are different than just throw more drugs at more symptoms, which is very akin to what you said with the IFM groups, et cetera. And the winds of change are upon us here. Having said that, one of the challenges that JP and I faced is that accepting that change is extraordinarily difficult. Insurers don't want to do it. There are stakeholders who don't want to do it. We talked about, we never even got to back pain, but there's going to be a pushback from those who want to do surgery to say, well, we still have to make sure that we can offer surgery, et cetera, et cetera. And that we've still struggled with broad acceptance of our therapies as being approved by insurances. So we have the science base. We need to continue to build on that scientific base. We need insurers to buy into this and pay for these therapies. And with that, we'll need large scale outcome studies, which JP and I started to try to do way back when. 2010, I think, was when we did that large study in the UK on coming up with new concepts of vagus insufficiency syndrome, which hashtag is the first chapter in my book, Vagus Nerve Stimulation, for those who are interested. But really the concept of saying, we're looking at the problem wrong. We're looking at this as splitters, not lumpers, and we need to come back to looking at the patient holistically and the importance of the autonomic nervous system. That's going to take patient's acceptance. It's going to take physician acceptance. And if without payers, we're going to be fighting a very difficult battle. So broadly speaking, I think the science is here. I think we have a lot of work to do on the reimbursement pathway. And then we need to flesh out why this may be better in comparative effectiveness trials. So that's my thoughts.
I love that. JP, any final thoughts as we conclude this conversation?
Just, a comment. I hope the science isn't over. I think there's so much more to learn, but I agree. I think one of the things that's a really amazing force that we've been able to bring to the game is when we started, the only way to get vagus nerve stimulation was with an implant, and now we have a handheld device, and it can be priced at a price that can really democratize this, where everybody can have access to it. I remember 20 years ago, I said, what would be my goal? My goal would be to make a lot of money making these things, and then after the patents run out, start a foundation and give them away for free, so that everybody on the planet Earth has one and they can use it. Because I think ultimately this is, we can joke, we can call it vitamin I, or vitamin V, a little bit of current, a little bit of voltage. And in the end, turn it into something that everybody on the planet can use. Because I think that ultimately, I don't know any human being who wouldn't benefit from this. Even the healthiest person out there, the top performers at the Defense Language Institute, they're doing 50% better. What does that mean for all of the rest of us?
Yeah, I wish I had it when I was a medical student, learning microbiology and being up all night, having less fatigue and being able to retain it a little bit better. That would have been wonderful for me. That was a new language for me. JP, I just want to blast from the past. To your point here, you made a Samsung phone. This was a phone at the time, and put on two little contacts on the back, to your points, that you could talk on the phone, and when your significant other or your boss yells at you a little too much, turn it over and stimulate because you're
reduce stress. Yep.
I cannot tell you how happy that made me, because JP's talked about that numerous times with me, and I've never once seen the prototype. That is very, very cool.
Oh, I've got one in my test drawer too.
I love that. You're going to have to bring it to Las Vegas to show me.
Okay.
That is awesome. I think it's such a cool thing, because we're attached to these things anyway. Why wouldn't we just be able to attach it to there and do that? Why?
There's a lot of acreage on the back of this. You don't have to mess with the camera, but there's a lot of other places you could put that.
I love it.
So
yeah, I think the camera's right in the middle on this one.
Yeah, that worked out. So you can actually take a photo of it while it's going. Make sure you're in the right spot. I love it. Gentlemen, this has been absolutely wonderful and very insightful. A wonderful conversation that I've been looking forward to for some time. So I'm excited to be able to be a part of it and share this with our audience. Very exciting stuff with regards to how it was developed and where it's going to take us in the future, and how we can truly help people enter that healing state where their bodies are given the right signals to enable healing to occur. Thank you for all your hard work, for all your effort in creating this, and thanks for being here. And so if you made it to this point in the podcast, please share this information with one person that you think could use this information. And I'm going to do a little tweak to the end here, because I think there's a lot of doctors that could use this information and actually be able to understand where non-invasive vagus nerve stimulation came from and how it can be utilized with their patients. So if you're a patient listening to this, share this with your doctor, your primary care physician, somebody that you think could utilize this information to help change the lives of so many people that are suffering from chronic disease. So take this time to share that. I appreciate you both for being here and for sharing all that wonderful information again. And for those of you at the end of this episode, we'll catch you on the next one.
Fantastic. Thank you, Navaz. Thanks, JP.
No problem.